Landfill sites are used to dispose of the waste generated from our lives. However, if proper landfill management is not carried out, adverse effects on the environment, such as bad odors, water pollution, and fires, will occur. Unfortunately, the current situation is that there are still problems with waste disposal sites in the world. The Fukuoka method is a groundbreaking construction method that makes effective use of the power of nature, is easy, low cost, and enables early stabilization. It was invented by Professor Emeritus Masataka Hanashima of Fukuoka University. Initially, the Fukuoka method was researched for practical use with the cooperation of Fukuoka University and Fukuoka City, and it is currently adopted as one of the standard structures for final waste disposal sites in Japan. In 2020, Fukuoka Prefecture released the Guide to Introducing the Fukuoka Method, Semi-Aerobic Landfill Method for Final Waste Disposal Sites in order to expand this Fukuoka method overseas. This video is an explanatory video made by Fukuoka Prefecture to support the introduction of the Fukuoka method to local governments overseas. If you want to have further explanation, check out the guide. The guide can be freely downloaded from the Fukuoka Prefecture website. Let's take a look at what kind of disposal site the Fukuoka method is from its structure. The Fukuoka method is also called the semi-aerobic landfill method. Compared to open dumping and anaerobic landfills, where oxygen is not supplied to the landfill layer, a feature of the semi-aerobic landfill method maintains an aerobic state by supplying air to the landfill layer through drainage pipes. In conventional anaerobic landfill methods, such as open dumping, leachate flows directly into the soil, contaminating the soil and groundwater, or greenhouse gases such as methane gas are emitted from waste, gases that may cause fires, and toxic hydrogen sulfide gas is generated in large amounts, and then the environmental impact is very high. The structure of the semi-aerobic landfill Fukuoka method promotes the decomposition of waste by microorganisms through the action of oxygen, suppresses the generation of methane gas and hydrogen sulfide gas, and reduces the environmental load compared to the anaerobic landfill method. So, we can contribute to the early stabilization of landfill sites. The Fukuoka method mainly consists of a gas venting system, rainwater collection and drainage system, groundwater collection and drainage system, leachate collection and drainage system, and leachate treatment system. By installing leachate collection and a drainage system consisting of cobblestone and perforated pipes at the bottom of the landfill, leachate in the waste layer is quickly drained to the leachate treatment system through perforated pipes. Since impermeable works, such as impermeable sheets, are laid, untreated leachate will not flow out of the landfill site into groundwater or rivers. Furthermore, inside the waste layer, heat convection occurs due to fermentation, heat generated by the decomposition of waste. This drainage of leachate and generation of heat convection reduces the water content of the waste layer, and air is supplied from the outside through the collection and drainage pipe, so waste being decomposed by microorganisms is promoted. What is the difference between the Fukuoka method and the conventional landfill method? Currently, in Thailand and Vietnam, the main method of final disposal is generally called open dumping, which is dumping type landfill or dumping up, and it's called the anaerobic landfill method. This anaerobic landfill method creates an anaerobic atmosphere in the landfill layer, not only posing sanitary issues such as the deterioration of leachate quality and offensive odors caused by the generation of hydrogen sulfide, but also has a risk of causing landfill fires and explosions by generating methane gas. In addition, the gases emitted from the landfill layer are called greenhouse gases and cause global warming and climate change. In particular, methane is about 28 times more powerful a greenhouse gas than carbon dioxide. And if the anaerobic landfill method continues, a large amount of methane gas will be released into the atmosphere. However, in the structure of the Fukuoka method, air naturally flows into the landfill layer through the leachate collecting and drainage pipe, which maintains an aerobic atmosphere and increases the activity of microorganisms, which can suppress the generation of methane gas and hydrogen sulfide. As a result, it is expected that the aerobic landfill method will improve the odor and stabilize the landfill site at an early stage. Another feature of the Fukuoka method is that it is designed so that leachate does not accumulate in the landfill layer, so it can be expected to improve the water environment both inside and outside the disposal site compared to the anaerobic landfill method. In addition, appropriate maintenance and management will stabilize the final waste disposal site at an early stage and reduce the cost of spraying chemicals during maintenance and management. This Fukuoka method has been highly evaluated internationally and is a technology that reduces emissions of greenhouse gases such as methane gas, as specified by the United Nations Framework Convention on Climate Change, UNFCCC. It is also recognized as a method of Clean Development Mechanism, CDM. In Japan, the sites of stabilized final disposal sites are used for green spaces, public facilities including sports facilities and multi-purpose plazas, and sites for solar power plants. In order for the Fukuoka method to function as a semi-aerobic landfill structure with low environmental impact, a leaching water collection and drainage system is indispensable. In this chapter, we will take a closer look at the function of leachate collection system and flow of water and air. The purpose of installing the leachate collection and drainage system is to prevent water retention by quickly discharging the water contaminated by the waste in the landfill layer to the out-of-sight leachate treatment system. At the same time, perforated leachate collecting and draining pipes supply air to the inside of the landfill layer to promote waste decomposition by microorganisms. To achieve this purpose, the leachate collection and drainage system will be equipped with 5 types of facilities. The functions required for each facility, such as collecting leachate and discharging generated gases like CO2, are different. In order to supply air from the outside through the drainage pipe, it is important to consider the necessary diameter of the drainage pipe at the design stage. Now, let's look at the water flow through the leachate collection drainage pipe. If it rains, rainwater comes in contact with waste and becomes polluted water. Leachate that has been contaminated by contact with waste is discharged to a leachate regulating pond outside the landfill layer through a perforated leachate collection and discharge pipe. For this reason, the leachate collection and drainage pipe is constructed on an angle so that the leachate flows smoothly to the leachate collection pit, as shown in the figure. Since leachate discharged to the regulating pond may contaminate the surrounding environment, groundwater, and the water area to which it is discharged, the leachate is properly treated at the leachate treatment facility before being discharged outside the site. Since the treatment flow and final discharged wastewater quality standards differ depending on the standards set by each country and local government, It is desirable to design a leachate treatment facility while consulting with local experts familiar with groundwater and water treatment. Appropriate management and treatment of leachate is the most important item in the operation of the Fukuoka method, so it is necessary to pay close attention to it. Next, let's take a look at the airflow. The internal temperature of the landfill rises because fermentation heat is generated by microbial decomposition of waste in the landfill layer. In the Fukuoka method, the laying of collection and drainage pipes generates heat convection due to the temperature difference between the inside and outside of the landfill site. As a result, air flows into the landfill site through the collection and drainage pipe in the opposite direction to the leachate flowing into the leachate collection pit. In this way, by constantly inflowing air into the landfill layer and maintaining the layer in an aerobic state, the activity of microorganisms in the layer is activated and aerobic microbial decomposition is promoted. The following points should be noted when constructing the leachate collection and drainage system. For example, in order to constantly send air into the landfill layer and maintain an aerobic condition, air should flow in from the outlet of the leachate collection drainage pipe. For that, it is necessary to keep the water level in the leachate collection pit lower than the end of the pipe. If you cannot manage that properly, air will not enter the landfill layer and it will become anaerobic, so you need attention to it. The purpose of installing a leachate treatment facility is to prevent leachate from contaminating the water area or groundwater to where it is discharged. Now, let's take a look at the example of general processing flow. This is the general flow of leachate treatment in Japan. Collected leachate goes through an inflow adjustment facility, calcium measures, biological treatment, coagulation sedimentation treatment, sand filter treatment, and advanced treatment, and it is then discharged after being disinfected. In addition, sludge is generated at the same time in the leachate treatment process, so sludge treatment is also required. Each treatment stage requires different functions. For example, in biological treatment, the purpose is to treat organic pollution, nitrify, and denitrify. Biological treatment is broadly divided into oxidation treatment and biological denitrification treatment. Specifically, treatment is carried out through an oxidation tank, a nitrification tank, a denitrification tank, and a re-aeration tank. In addition, functions such as COD removal, chromaticity removal, and heavy metal removal are required for coagulation sedimentation treatment. Sand filtration treatment requires a function to remove suspended solids, while advanced treatment requires functions to remove COD, chromaticity, and heavy metals. In particular, the design policy for the leachate treatment system will vary depending on the quality of the leachate, the location of the disposal site, and the type of waste. It is better to consider this after consulting with local experts. In this chapter, we will explain the seepage control installed in the landfill. The function of the seepage control is to prevent seepage water from flowing out of the site, allowing all seepage water to be collected in the seepage water collection and discharge pipe and properly discharged to the drainage facility. Therefore, it is necessary to proceed with caution so as not to impair the function of the seepage control during construction. Mainly as 2 points. 1. Preventing damage to seepage control sheets. 2. Grasping the environmental conditions. The seepage control sheet prevents the outflow of leachate contaminated by contact with waste, so even if it is a small one, if it has a hole or is damaged, it will not be able to perform its function, and the leachate will leak to the surroundings and will cause environmental pollution. The use of a protective mat is effective as a material to prevent damage to the seepage control sheet and protect it. By laying a protective mat on top of the seepage control sheet, you can expect not only to protect the seepage control sheet, but also to prevent deterioration due to direct sunlight. This protective mat is made of polyester fiber non-woven fabric, recovered felt, and other materials. Materials such as synthetic rubber, asphalt, and bentonite are used for seepage control sheets. But depending on the material used, the weather and temperature at the time of construction has an effect. For instance, when the temperature is high, the impervious material may expand, and conversely, it may shrink when the temperature is low. If the construction is performed under high temperature conditions, there is a risk that the seepage control sheet will expand or contract when the temperature drops. So, it is necessary to devise construction when the temperature is low. And, avoiding construction when the surface of the seepage control sheet is wet due to rain, it is better to work in a dry state to maintain the state of the sheet. It is also important to ensure that there is no unevenness on the ground in contact with the seepage control sheet. If there is unevenness, pressure will be applied when the waste is landfilled, and the sheet may be damaged. If the ground contacting the seepage control sheet is affected by rainwater and so on, the shaping condition is not good. It is necessary to reshape it. In that case, for example, you can use soil mixed with cement to reinforce it. At seepage control, it is difficult to detect and repair damage once landfilling of waste begins, so sufficient care must be taken during construction. Once the design and construction of the Fukuoka method is completed and landfilling of waste begins, maintenance and management to maintain semi-aerobic conditions will be required. In order to operate the disposal site stably until its closure, it is necessary not only to construct the disposal site, but also to properly maintain and manage the disposal site after its completion. Maintenance and management mainly include work such as carry-in management, landfill, covering soil, installation of subsidence plates, monitoring, etc. And now, we will introduce particularly important items. Monitoring is one of the most important response items in maintenance and management. It is necessary to grasp the situation through regular monitoring so that waste, leachate, landfill gas, and so on do not affect the surrounding environment. In general, the required measurement items differ depending on the object of monitoring, such as leachate and groundwater. The items to be actually measured are set and implemented based on the standards and related laws and regulations established by each country and local government. In the measurement, it is necessary to utilize the knowledge of each engineer and expert, and if the standard is exceeded or an abnormality is found, it is necessary to quickly identify and solve the problem. In the Fukuoka method, collection and management of leachate is very important. Without proper management, it will adversely affect the surrounding environment and hinder the early stabilization of the landfill site. During the maintenance and management of the leachate collection and drainage pits, regular checks are made to ensure that there is no accumulation of dust, sand, and so on in the pits. Depending on the situation in the pit, we clean the pit with high-pressure water to maintain a state in which water can be sent to the leachate regulating reservoir. However, care must be taken when cleaning the leachate collection pit. We always measure the oxygen concentration in the pit and the concentration of gases that are toxic to the human body, such as hydrogen sulfide, in advance, and start work after confirming that the safety of workers is ensured. As explained so far, efficient and appropriate treatment of leachate and rainwater is extremely important in the Fukuoka method. However, if more rainfall occurs than expected at the design stage, there is concern that not only will the amount of rainwater discharge temporarily increase, but the amount of leachate will increase at the same time. Since there is a limit to the amount of leachate that can be treated by leachate treatment facilities, it is necessary to reduce the amount of leachate as much as possible and to drain it as rainwater, even in emergencies such as heavy rain. In case of an emergency such as heavy rain, depending on the situation of landfill work, a sheet is placed on top of the cover soil. In order to separate leachate and rainwater, a dividing embankment will be installed. A pump will be installed on the partition bank to discharge water into the rainwater gutter through a discharge hose. Remove the sheet promptly after completing the rainwater removal work. We must think about these such measures.
สวัสดีครับผมนายปรีชาจันทรลงทองนายกเทศมนตรีเมืองสีคิ้วบ่อฝังกบขยะมูลฝอยแบบถึงใช้อากาศของเทศบาลเมืองสีคิ้วจังหวัดนครราชสีมามีพื้นที่ที่สามารถรองรับขยะจากครัวเรือนได้ประมาณ 18,000 ตารางเมตรในอดีตเทศบาลเมืองสีคิ้วจังหวัดนครราชสีมาเคยใช้วิธีการกำจัดขยะในรูปแบบการฝังกบแบบไม่ใช้ออกซิเจนมาก่อนซึ่งวิธีนี้หากบริหารจัดการไม่ดีจะส่งผลกระทบต่อสิ่งแวดล้อมและสุขอนามัยต่อประชาชนในพื้นที่เป็นอย่างมากจนกระทั่งในปีพ.ศ. 2559 เทศบาลเมืองสีคิ้วจังหวัดนครราชสีมาได้เข้าร่วมเป็นพื้นที่นำร่องโครงการความร่วมมือระหว่างจังหวัดฟุกุโอกะประเทศญี่ปุ่นกับกรมควบคุมมลพิษประเทศไทยในการปรับปรุงระบบกำจัดขยะมูลฝอยให้ถูกต้องและถูกหลักสุขาภิบาลโดยใช้ระบบฝังกบขยะมูลฝอยแบบวิธีฟุกุโอกะซึ่งเป็นวิธีการฝังกบแบบกึ่งใช้อากาศโดยวิธีการนี้เป็นวิธีที่สามารถลดกลิ่นไม่พึงประสงค์ปัญหาหนูนกและแมลงได้อีกทั้งยังช่วยปรับปรุงสิ่งแวดล้อมรอบๆสถานที่กำจัดขยะมูลฝอยเช่นไม่มีน้ำชะขยะไหลปนเปื้อนกับน้ำผิวดินและน้ำใต้ดินรวมทั้งไม่ส่งผลเสียต่อสุขภาพและอนามัยของประชาชนในละแวกใกล้เคียงบ่อฝังกบขยะมูลฝอยแบบกึ่งแช่อากาศด้วยวิธีฟุกุโอกะของเทศบาลเมืองสีคิ้วจังหวัดนครราชสีมาได้รับความสนใจทั้งจากภาครัฐและภาคเอกชนเป็นอย่างมากโดยมีคณะศึกษาดูงานมาเยี่ยมชมพื้นที่รวมประมาณ 4,000 คนทั้งนี้เทศบาลเมืองสีคิ้วจะดูแลรักษาบ่อฝังกบนี้ต่อไปอย่างเหมาะสมและเผยแพร่ข้อมูลอย่างต่อเนื่องรวมทั้งให้คำแนะนำแก่ผู้เข้าชมเกี่ยวกับวิธีแก้ปัญหาที่ยั่งยืนต่อไปขอบคุณครับ